Okay, let's start. So, if you do remember, we are going to study the course that is about data communication and computer networks, DCCI. Okay, so if you do remember, in the last class we had discussed chapter number 3. It was about transport layer, and we had discussed the TCP. Okay, so in the TCP we have reliability. Okay, so before discussing that how the TCP achieve reliability, so we have discussed that what is reliability and how can it be achieved at the transport layer. So for this purpose, we were assuming some scenarios, and until now we have discussed RDT 1.0 protocol, RDT 2.0 protocol, and RDT 2.1 protocol. So these topics have been discussed in the last class. Okay, now we are going to continue in the chapter number 3. We are going to continue chapter number 3, transport layer, and it is from the computer networking, a top down approach, 7th edition. So we will give you RDT 2.1 an overview, okay, and then we will discuss RDT 2.2 protocol, RDT 3.0, and pipeline protocol. Okay, so this is all about the today's class topics. Okay, so if you do remember, so in the last class we have discussed RDT 2.1, and the RDT 2.1 we have assumed that the underlying network layer, which is transferring the data physically from source machine to destination machine, suppose that has bit error. So if that has the bit error, so how we can cope with the bit error, how we can achieve reliability in case of bit error in the underlying network. So we had discussed RDT 2.1. In this RDT 2.1, we have discussed that first of all we should compute the checksum. At the center side, we should compute the checksum. Why? Because the checksum is a mechanism that is used to check that whether the data has bit error or not. Okay. So the sender computes the checksum and then sends the data. Okay. When the sender transmit the data, so the sender also keep one copy of the packet. Why? Because if the receiver receives the data, then the receiver check the data for error. If there is an error, okay, so the receiver will discard. What is error? If the packet has bit error. And how the receiver comes to know that the data and the packet has the bit error? So through checksum. So we have already discussed it. Okay, so if the receiver receives the data and the data has the error, so the receiver will discard the data. Okay, and the receiver will send feedback. What is the feedback? The feedback will be negative acknowledgement. So when the sender receives negative acknowledgement, then the sender has already stored one copy of the packet. So that copy will be one copy of that packet will be retransmitted, and again one copy will be kept. Okay, why? Because this retransmitted packet can also have bit error. Okay, so we use the checksum, retransmission, and feedback mechanism. Okay, and then we also discussed that this sequence number, this acknowledgement and negative acknowledgement, they can also be corrupted. Okay, so if that can be corrupted, so we have discussed that we don't use feedback for acknowledgement and negative acknowledgement. We only compute the checksum for acknowledgement and negative acknowledgement. Okay, but we don't use the feedback mechanism for acknowledgement and negative acknowledgement. Why? Because the probability of error in the acknowledgement and negative acknowledgement is less as compared to data. Okay, so but there is the probability that acknowledgement or negative acknowledgement can be corrupt. So acknowledgement can become negative acknowledgement and negative acknowledgement can become acknowledgement. So if this is the case, so what will happen? That happens that if acknowledgement becomes negative acknowledgement, then there is redundant transmission. We have already discussed it. And if negative acknowledgement becomes acknowledgement, then there can be packet loss. So how to detect the packet loss or how to detect the duplicate packet? So we use sequence number. With each data packet, when we send, we attach the sequence number. And since we are using stop and wait means when one packet is transmitted, so the next packet will not be transmitted until and unless the first packet is received at the receiver. Okay, so therefore we use only the sequence number 0 and 1. 0 and 1 and they are suffix. Okay, so this through this sequence number, the receiver can detect duplicate packet. If there is a duplicate packet, then through sequence number it can come to know. So the duplicate packet will not be delivered to the application. Okay, so we have already discussed this RDT 2.1 protocol. Okay, so if the packet is received and it is duplicate, then through sequence number it can come to know the receiver that the packet is duplicate. Okay, so we have assumed that the sender when send the data, so it compute the checksum, it use the retransmission mechanism, the receiver and sender, the receiver sends the feedback, and with each data packet we attach the sequence. Okay, so we have discussed it, and the receiver for acknowledgement and negative acknowledgement we don't use feedback mechanism. So if acknowledgement or negative acknowledgement can be lost. Okay, so but we have until now we have discussed that only the medium, the underlying network layer, it has bit error. It doesn't have the packet loss, doesn't have the packet loss. So if there is the bit error in the acknowledgement or negative acknowledgement, then it can lead to duplicate packet. And we have already discussed we use the sequence number to the data packet, so it cope with this problem. Okay, so we have already discussed this RDT 2.1 protocol. Okay, now we are going to design and discuss another protocol that is called RDT 2.2. And this protocol is negative acknowledgement free protocol. What does it mean? It means that for the feedback mechanism, this RDT 2.2 protocol, it has the same functionality as the RDT 2.1 that we have discussed in the previous slide and we have discussed in the previous lecture. So it's RDT 2.2, it has the same functionality as RDT 2.1. But what is the difference? The difference is that RDT 2.2 it use only acknowledgement. It doesn't have negative acknowledgement. So that's why RDT 2.2 is called negative acknowledgement free. From the acknowledgement, we get the meaning of positive acknowledgement as well as the negative acknowledgement. Okay, so that's why only this receiver sends acknowledgement. The receiver doesn't send the negative acknowledgement. But from the acknowledgement, the sender can come to know that whether this is a positive acknowledgement or negative acknowledgement. How it is done? Why it is done? Instead of negative acknowledgement, so the receiver sends acknowledgement for the last packet that is received. So it means that with the acknowledgement, we also sends the sequence number. We also send the sequence number, and the acknowledgement is sent for the last packet that is received. Okay, that is received. Okay, okay, so with this and how it is sent through sequence number, so we will discuss it that how acknowledgement and with the sequence number it can be detected as a positive acknowledgement or negative acknowledgement. So we don't use negative acknowledgement. In the RDT 2.2, we don't use negative acknowledgement. We use only acknowledgement, and from the acknowledgement, we get the meaning of negative acknowledgement as well as positive acknowledgement. How it is done? Let's me explain it through an example. Okay. So in the previous class, we have discussed that we attach the sequence number to each packet. Okay, and now in the negative acknowledgement free protocol, we attach the sequence number to the acknowledgement as well. And that acknowledgement, the sequence number should be the for the last packet that is received. Okay, that is received. Okay, so in this way, we don't need the negative acknowledgement. Okay, so it means, so therefore it is called additive 2.2 is called a negative acknowledgement free protocol. Let me explain it through an example. Okay, so for example the sender sends the packet p0 and p1. Okay, so if p0 is received correctly, okay, so the sender will send acknowledgement 0, that the packet up till acknowledgement the sequence number 0 is received correctly. If P1 is received sent and it is received correctly, so it will send acknowledgement 1, that up to acknowledgement to packet number 1 the data is received correctly. Okay, so now the receiver has received the two packet, acknowledgement 0, packet number sequence number 0, packet with the sequence number 1. Now the receiver is waiting for which packet? For the third packet. And what should be its sequence number? Because we are assuming that the sequence number is up to now it is 0 and 1. So the first packet it will have sequence number 0, the second will have sequence number 1, and third packet again it will have sequence number 0. Fourth will have sequence number 1. Fifth will have sequence number 0. Sixth will have sequence number 1. Okay, in this way. So in this way you can see that, so in this case P0 it is received correctly, P1 is received correctly. So when P0 is received correctly, so acknowledgement 0 is sent by the receiver. When P1 is received correctly, so acknowledgement 1 is sent by the receiver. Okay, so now the receiver is waiting for the next packet, third packet with the sequence number 0. Okay, now suppose that the sender sent the third packet P0 and it is received with error. It is received with error. It has bit error. So what should be the acknowledgement number? So the acknowledgement number should be what? The receiver sends acknowledgement for the last packet that is received. Okay. So here, what is the last packet that is received? Okay, that is received correctly. So this is the last packet that is received correctly. And what is its sequence number? Sequence number is 1. So it will send acknowledgement number of 1, not acknowledgement P0. Why? Because P0 is received with error. So if it is received with error, so the receiver will send the acknowledgement for the last packet. For the last packet that is received. Okay. So the last packet that is received correctly, it is this packet, acknowledgement number 1. So this acknowledgement will be sent. The last correct acknowledgement, it will be sent. So in this case, the acknowledgement will be 1. Okay. So this will acknowledgement number 1 will be sent. Now again, suppose that the sender sent the third packet P0 again, retransmit it, and it is received correctly. So it will send the acknowledgement. Now this packet, this P0, it is received correctly. So this is the last packet. This is the third packet. So what should be? It is received correctly. So if it is received correctly, okay, then the receiver should send the acknowledgement for the last packet. Now P3 will become the last packet that is received correctly. Okay, so in this case, what should be the acknowledgement number? The acknowledgement number for this packet. The acknowledgement number for this packet will be acknowledgement 0. Okay, so in this way, by sending the acknowledgement number, we can get by receiving duplicate acknowledgement. Why? Because acknowledgement 1 is sent 1 for this packet, and it is sent for the first time for P1 packet. And when the third packet P0 is sent and it is received with error, So the receiver discard this, and the receiver send the acknowledgement for the last packet that is received correctly. So this is the last packet that is received correctly. So it will send acknowledgement number 1. So the sender will receive acknowledgement number twice, one for P1 and one for P0. So when the acknowledgement number is received twice, duplicate. So this is the indication that the third packet P0 is not received correctly. Okay, so through duplicate acknowledgement number, the sender can come to know that the last packet, and what is the last packet? This is the P0 that is transmitted. It is not received correctly. It is received with error. So it is received with error. So P0 should be retransmitted. Okay, so by sending the acknowledgement for the last packet that is received correctly, so by including the sequence number with the acknowledgement number, so it avoids the negative acknowledgement. So it doesn't need negative acknowledgement. Okay, so we use only acknowledgement and we get the meaning of acknowledgement and negative acknowledgement. Okay, so I think now it is clear to you. Okay, now let me explain the working of RDT 2.2 through some more examples. Okay, so suppose that the sender sends packet 0, packet with the sequence number 0. The receiver receive it correctly. So it will send the acknowledgement 0 because this is the last packet that received correctly. So it will send acknowledgement 0. Okay, so suppose again the sender sends next packet that is P1. Okay, we are using the sequence number 0 and 1. So P1 is sent and packet 1 is received correctly. So it will send the acknowledgement number 1. Okay. Now, similarly, if the sender sends the third packet, so its sequence number will be 0. Why? Because we are assuming the sequence number 0 and 1. Okay. So P0 is packet 0 is received correctly. So it will send acknowledgement number 0 because this is becomes the last packet that is received correctly. And for this acknowledgement, for this packet, the acknowledgement should be acknowledgement 0. Okay. Now we are going to discuss another example. Suppose the sender sends packet number 0. So it is received correctly. So this is becomes the last packet that is received correctly. So what should be its acknowledgement? Acknowledgement should be acknowledgement 0. Okay. So acknowledgement 0 is transmitted. Okay. Now suppose that the sender sends the second packet, packet number 1. Its sequence number will be packet 1. Why? Because we are assuming the sequence number 0 and 1. Then suppose this packet number 1, it is received with error. It has bit error. So the receiver will discard it. But the receiver will send acknowledgement. Acknowledgement for the last packet that is received correctly. So this is the last packet that is received correctly. And its acknowledgement is acknowledgement 0. So in this case, it will send acknowledgement 0. It will send acknowledgement 0. Okay, so when the acknowledgement 0 is received, so acknowledgement 0 is received twice because acknowledgement 0 is received once for packet number 0 and acknowledgement 0 is received second time for the packet number 1. So through duplicate acknowledgement number, the sender comes to know that the last packet that is transmitted, that is the last packet is packet number 1 that is transmitted by the sender. So it is received with error. It is received with error. So through duplicate acknowledgement number, the sender comes to know. So it means that the last packet, that is the packet number 1, it is received with error. So that's why packet number 1 is retransmitted. So when packet 1 is received correctly, so the sender will send the acknowledgement number 1 because now packet 1 becomes the last packet that is received correctly. And for this packet, the acknowledgement number is acknowledgement number 1. Okay. Now let me discuss its FSM. Okay, its FSM. So what is it? The sender FSM? The sender is in each FSM we have initial state. So initial state is which one? Which has this dash line. Okay, so here the sender is waiting to receive the data from above. From above means from application layer, because we are working at transport layer. So when it receives the data from the application layer, so first of all it makes the packet, and it makes the packet, so it also compute the checksum. Why? Because this underlying channel have bit error, and it attach the sequence number, because in order to detect the duplicate packet. Okay, and then it sends the packet, and one copy of the packet is stored, and now the sender is waiting for acknowledgement 0. If it receives the acknowledgement 1, it means this acknowledgement 0 is lost, because the packet 0 is transmitted, acknowledgement 1 is received. So this is it, this is the, so it means that packet 0 is lost, so the packet 0 is retransmitted. It is retransmitted. But if acknowledgement 0 is received, so it means that packet 0 is delivered correctly, so it will send the next packet, will send the next packet. Okay, so this is how it works. Okay, so if packet is transmitted, it is received correctly. Okay, so if it's received acknowledgement 0, then it means that next packet will be transmitted. Okay, and this is the FSM for the receiver side for RDT 2.2. I think I have explained it through example. This will be easy for you to explain it. Okay, so I think so here the it is waiting for the data from below. From below means, because we are working at transport layer, so it is waiting to receive the data from network layer, and the network layer, it can have bit error. Okay, so when it receives the data and it has sequence number 1, it is waiting for packet number 0, and it is received packet number. Okay, so if it is corrupt, it has sequence number 1. Okay, so it will send the packet, it will send the negative acknowledgement. Okay, but if it has received the data correctly, it is not corrupt. Okay, and it it will then it will extract the data, and it will send the acknowledgement number 0. Okay, this is the acknowledgement number 0. Okay, so we have already discussed it. Now I think this FSM you can study it by yourself. Okay, so we have discussed RDT 2.2 protocol. Okay, I think it is clear to you. Okay, now let me remind to you, let me remind to you what is reliability and why it is important. Okay, so reliability means that the data is received without bit error. The data is received without loss, and the data is received in the order that is sent by the sender. In this protocol, RDT 2.0, RDT 2.1, RDT 2.2, we assume that this underlying channel, the network layer, it can have bit error. So if it can have bit error, so what should the transport layer does? What should the transport layer do in order to achieve reliability if the underlying channel have bit error? So for this purpose, we have discussed RDT 2.0, RDT 2.1, and RDT 2.2. So RDT 2.2, it is a complete protocol that it can be used a transport layer to achieve reliability in case the underlying channel has bit error. Okay, now we are going to discuss the next parameter. That is, if this underlying channel, the network layer, it can also lose the packet. It can also lose the packet. So along with the bit error, this underlying channel also has the packet loss. that is the packet can be lost. Then what should transport layer do in order to achieve reliability? Okay, so for this purpose, we are going to discuss RDT 2.3.0. So RDT 3.0, it can work to achieve the reliability transport layer if this underlying channel, the network layer that is used to physically transfer the data from sending machine to receiving machine, if this underlying channel have bit error as well as packet loss. So how? Let's discuss the RDT 3.0. Okay, so RDT 3.0, it assumes, what does it assumes? It assumes that the underlying channel can have bit error as well as packet loss. So if it has packet loss along with error, so what should we do? Okay, so the new assumption is that the underlying channel, the network layer, can also lose the packet. What does it mean? Packet means that the data can be lost, the data packet can be lost, or the acknowledgement can be lost. Why we didn't discuss the negative acknowledgement? The negative acknowledgement can also be lost. So why we discussed that only data packet can be lost, acknowledgement can be lost? Because in the RDT 2.2 protocol, RDT 2.2 protocol, we have discussed RDT 2.2 protocol. This is negative acknowledgement free. We don't use negative acknowledgement. We use only acknowledgement and we get the meaning of acknowledgement and negative acknowledgement. Okay, so that's why the underlying channel can have packet class. Okay, so by packet class, what does we mean? We mean that the data packet can be lost or the acknowledgement can be lost. So if the underlying channel can experience packet loss, data packet or the acknowledgement can be lost, then whether the already we are using checksum, sequence number, acknowledgement, and a sequence number with acknowledgement numbers, and retransmission, they are helpful, they are enough, they are sufficient? Not. They are not sufficient. Why? Because suppose this sender is sending the packet number 1 and it is lost. It is not received to the receiver. So how the sender comes to know that the packet is not received? So if the packet is received, then it can send the acknowledgement or negative acknowledgement. If the packet is not received at the receiver, then how the receiver comes to know that, then how the sender comes to know that the packet 1 is lost? Because the receiver will not send acknowledgement or negative acknowledgement. Why? Because the receiver has not received the packet. The packet is lost in between. Okay, and why it lost? Maybe that the packet is received at a router and the router buffer is full, so the packet is lost. Okay, so in this case, this checksum, the sequence number, acknowledgement, retransmission, they are not helpful. So what should we do? How the sender can comes to know that the packet is lost? So the sender can come to know that the packet is lost by using time. The send timer. The sender should wait for a reasonable amount of time for acknowledgement. If the sender transmit the packet number 1, then it will wait for certain time. If within that time the acknowledgement or negative acknowledgement is not received, the acknowledgement doesn't come, the feedback doesn't come, it means that the packet is lost or the acknowledgement is lost. In either case, the sender should retransmit the packet after the timer expires. After the time expires, the packet 1 will be retransmitted. Okay. So in this case, what does it mean? Okay. Okay. So this is the case that when the sender sends the packet 0, so it will wait for reasonable amount of time. So it will start a timer. It will start a timer. If the acknowledgement is received within that timer, then when the acknowledgement is received, that timer will be will be cancelled. The next packet will be sent. When the next packet is sent, again the timer is started. If the acknowledgement is lost, this acknowledgement one is lost, so this the sender doesn't receive acknowledgement, so its timer will be expired. When this timer is expired, this packet one will be retransmitted. Okay, so if within reasonable amount of time acknowledgement is received, for example for packet number 0, acknowledgement is received within reasonable amount of time, within that timer, so the timer is cancelled and the next packet is sent. Again, for each packet, that when the packet is sent, transmitted or retransmitted, the timer is set. It is on. It is set. So the timer is now on. And when the acknowledgement is lost or the packet is lost, so the sender doesn't receive acknowledgement within this timer, this time. So what should it do? It retransmit if no acknowledgement is received in this time. Okay, so this packet will be retransmitted. Okay, so if this packet is retransmitted, then retransmission may lead to duplicate. Why? Because you can see that this packet can be lost, or this acknowledgement can be delayed. It is delayed than this timer. So this packet one is retransmitted. So it means that packet one is received twice at the receiver. So it led to the retransmission may lead to duplicate. That the receiver can receive the packets duplicate, but the receiver already used sequence number. So through sequence number, it can identify that the packet one is duplicate. So the duplicate packet, it is not delivered to the application, but it will sense the acknowledgement number one again. It will sense the acknowledgement for each packet received, that is received correctly or incorrectly. Why? And even if it is received duplicate, retransmitted, again it will send the acknowledgement, because it doesn't know whether this acknowledgement is lost or not. Okay, so the receiver must specify the sequence number of the packet being acknowledged that we have assumed. Okay, why? Because through duplicate acknowledgement number, the sender can come to know that okay, the last packet is lost. Okay, so in order to cope with the underlying channel packet can experience packet loss. So how we can address this problem? We can address this problem by using the countdown timer. What does it mean? That whenever the packet is transmitted, a countdown timer is started. If within that timer, this time, the acknowledgement is received, then the timer will be cancelled and the next packet will be transmitted. If the timer expires and the acknowledgement is not received, then that packet will be retransmitted. Okay, so but if the underlying channel can have the packet loss, so we can use countdown timer along with the checksum, along with the sequence number, along with the retransmission mechanism, along with the feedback mechanism. Okay, so I think it is clear. RDT 3.0, it use the countdown timer along with the sequence number, along with the acknowledgement, along with the checksum, along with the feedback mechanism. Okay, now this is the FSM for the RDT 3.0. Okay, so I think it is easy for you, so you can also you can read it in the book, and you can I think it is very clear. Okay, so if it is received the data, so it is the starting state from the above layer, then it makes the checksum data packet and it's in the packet number 0. Its sequence number is 0. Why? Because we are using the sequence number 0 and 1, and when the packet is transmitted, then it starts the timer. Okay, so this is the new. Why it is new? Because if the underlying channel can have packet class, so when it is waiting for the acknowledgement 0. If the timeout happens, the timer is expired, then that packet will be retransmitted, because one copy is already stored with the sender, and the timer will be again restarted. Okay, and if the acknowledgement is received correctly, then it means that it will send the packet number next one, packet number 1. Okay, so now we are going to discuss the RDT 3.0 through examples. Okay, so suppose the sender sends packet number 0. So when packet number 0 is transmitted, the timer will be started. It is received correctly, so it will send acknowledgement number 0, because this is the last packet that is received correctly. So when the acknowledgement 0 is received within the timer will be cancelled. The next packet will be transmitted. Packet number 1. Packet number 1 is transmitted, the timer will be set. If within this time, suppose the packet 1 is also received correctly and it sends acknowledgement number 1, so within the timer the acknowledgement is received, so the timer will be cancelled. Similarly, the next third packet will be transmitted. The third packet, it will have sequence number 0. Why? Because we are using 0 and 1 sequence number. We are sending one packet at a time, so 0 1 sequence number is enough. So this is the third packet is also received correctly, so it will send acknowledgement number 0. Okay, now suppose this example, the packet number 0 is transmitted, the timer is on. Packet 0 is received correctly, so the receiver will send the acknowledgement 0. Acknowledgement 0 is received, so this timer will be cancelled for packet number 0, and the second packet is transmitted. Now second packet 1 is transmitted, suppose it is lost, so the timer is on. Okay, so now the timer will expire and it will not receive, so the time out is expired, the timer is expired, it is out. So if the timer is expired and no acknowledgement is received, so it means that the packet 1 is lost or its acknowledgement is lost. So in this case the packet 1 is lost. Okay, so it will send the packet 1 again, it will resend the packet number 1. Okay, when it's resend the packet number 1, so again it will start the timer. It is received correctly, so it is received for the first time, because packet number 0 is received, then packet number 1, so packet number 1 will be delivered to the application layer and it will send the acknowledgement number 1 for packet number 1. Now when acknowledgement number 1 is received, so the timer for packet 1 be stopped, cancelled, and third packet will be sent. The third packet, it will have sequence number 0. Why? Because we are using sequence number 0 and 1. Okay, so what is the difference here between this example and the last example we have discussed in the last slide? So in this example, okay, so in the last example, if you do remember, so here the acknowledgement was delayed. So here the packet 1 was received twice, duplicate. So through sequence number, the duplicate packet was identified by the receiver. So duplicate packet means that the receiver will discard this packet, but it will send the acknowledgement number 1. Okay, and because it is duplicate, so it will discard it. It will not be delivered to the application, but it will sense the acknowledgement. Okay, and here in this example, packet number 1 is lost. So again the timeout is expired and packet 1 is retransmitted. So here packet 1 is received once at the receiver side. Okay, now some more examples. Okay, what you can see, that packet number 0 is transmitted, it is received correctly, so acknowledgement 0 is transmitted. Now the sender sends the second packet number 1, it is also received correctly and the receiver sends the acknowledgement number 1, but this acknowledgement is lost, so the sender will not receive the acknowledgement, so the timeout will expire. When the timeout expires, so the sender will resend the packet number 1. Okay, so when it will resend the packet number 1, so it is received duplicate. Why duplicate? Because through sequence number, the receiver can identify that the packet number 1 is duplicate. Packet number 1 is already received. So duplicate packet, they are deleted. They are not delivered to application. But in any case, it will again send the acknowledgement number 1. Acknowledgement number 1. Okay, when acknowledgement number 1 is arrived, so it means that packet number 1 is received correctly. Okay, so whether the receiver receives the packet for the first time correctly or it is a duplicate packet, so in either case the acknowledgement will be sent for each time. Acknowledgement will be sent each time. Okay, now let's discuss this scenario. The sender sends the first packet, packet number 0. It is received correctly, so the receiver sends acknowledgement number 0. Acknowledgement 0 is received within the timer, so the timer will be cancelled. It will be stopped. The second packet is transmitted, packet number 1. Its timer is started, and suppose its acknowledgement is the packet 1 is received correctly, so the receiver sends the acknowledgement 1. And suppose this acknowledgement get delayed, it get delayed. So if it is delayed and the timeout is expired, so the packet 1 is retransmitted. Okay, so here the packet 1 is received duplicate. So how the receiver detects that this packet is duplicate? Through sequence number. Packet 1 is received twice, so it is duplicate. So duplicate means that this packet will be discarded. It will not be delivered to application layer. However, it will send its acknowledgement. And what should be its acknowledgement? So this is the last packet that is received correctly. So the acknowledgement will be acknowledgement number 1. Okay, so acknowledgement number 1 is retransmitted. When acknowledgement number 1 is retransmitted and it is received, so acknowledgement 1 is received twice. Why 1 is received here? It was received delayed. Okay, so when this acknowledgement 1 is received, so it means the sender will come to know that this packet 1 is received correctly. The sender doesn't know that this acknowledgement for this packet 1 or for this packet 1, but the sender will assume that this acknowledgement for this packet, that is the last time the packet is transmitted. So the last time packet is transmitted, this is the recent packet number 1. So it will assume that the packet number 1 is received correctly. This recent packet is correctly. So what does it mean? So it will stop the timer of packet 1 and it will send the third packet. The third packet will be packet number 0. When this packet 0 is transmitted, then it received acknowledgement, the sender received acknowledgement number 1 again. Why? This acknowledgement 1 is for this recent packet. This recent packet is received correctly, so it sends the acknowledgement. So this acknowledgement 1 is received duplicate. Acknowledgement 1 is received first time here and acknowledgement 1 is received second time. This acknowledgement 1 is for this packet, but the sender doesn't know that this acknowledgement is for this packet or for this. So the sender knows that this will assume that this acknowledgement is for the last packet, and the last packet is this recent packet number 1. Okay, so the sender assumes that this acknowledgement is for this recent packet number 1. So that's why it stopped the timer of this recent packet number 1 and it retransmitted the packet number 0. And when packet number 0 is transmitted, 0 is transmitted, the third packet acknowledgement 1 is arrived. This acknowledgement is duplicate. Okay, through acknowledgement number. So when we assume that when the duplicate acknowledgement is received, so it is the negative acknowledgement. It means negative acknowledgement. It means that the last packet that is transmitted, it is received incorrectly. The last packet is packet number 0. So this packet 0 is received incorrectly. Although it is not the case. This acknowledgement 1 is for this recent packet. Okay, so the sender will assume that this acknowledgement is duplicate. So it means that the last packet that is transmitted, the last packet is packet number 0. So the third packet, it is transmitted, so it is received with error. It is received with error. So it will sense the packet number 0 again. Okay, but although this is not the case, so the premature timeout means that when the timeout is expired before acknowledgement is coming, then the delayed acknowledgement is delayed. So this can lead to retransmission of multiple packets. You can see that packet 1 is retransmitted and packet 0 is also retransmitted. Here packet 0 is also retransmitted. So packet 0 is also received duplicate. So this led to duplicate transmission. Duplicate transmission. So it used the energy, the medium. Okay, so the timeout, it should be equal to acknowledgement. We will discuss it later on. This timeout value should not be random. It should be equal to acknowledgement the actual time. If it is greater than this, if this timeout is less than the actual time, the actual time is from here to here, is this the actual time, and the timeout is less than actual time, then this leads to premature timeout. What does it mean? That it leads to multiple retransmission. Packet 1 is retransmitted, packet 0 is also retransmitted. So when multiple packets are retransmitted, so it leads to redundant transmission. It uses the energy, the medium. Okay, so it should be avoided. How it can be avoided? How this can be avoided? This retransmission can be avoided if this time out is equal to the actual time, that is taken by packet from sender to receiver and acknowledgement from this. So we will discuss it that how we can compute this timeout. Okay, so we will discuss this through in the next video, this from this lecture. Okay.